Why does it feel like your AI agent has the memory of a goldfish? You're asking it to refactor a complex function, it does it, and then 5 minutes later, it forgets the context of the entire project. This is annoying, but also expensive. Every time your agent forgets and has to reread your codebase, your API bill shoots up and your latency crawls. The secret isn't to make the model smarter, but rather manage its memory and context. Today, we are analyzing how this AI memory war works with one giant and one newbie who is already breaking the norm: Claude Code versus OpenClaw. In this video, we are going to break down how these two manage persistence so you can choose the right one for your production pipeline. We'll cover Claude Code, its 4-level architecture and its approach to behavioral memory via Claude Mem. OpenClaw and how it manages agentic memory for autonomous tasks. The technical distinction between memory and context caching. And finally, a strategy for building systems that are safe and future-proof, not just optimized for today. Before we begin, don't forget to subscribe to our YouTube channel for more AI and software development insights. First up, Claude Code. Think of this as your workbench assistant. It lives in your terminal and understands your local file structure. Claude Code manages memory through a very specific 4-level hierarchical architecture. This is how the agent prioritizes your instructions. 1. Enterprise policy. Top-level rules set by your organization. 2. Project memory. This is your team's source of truth. 3. Modular rules. Instructions that load dynamically based on the file that you're editing. 4. User memory. Your personal preferences kept in your home directory. Now, here is the technical goal from our engineering team. What's your token count? A 100-line Claude file uses about 4,000 tokens. To keep Claude fast and precise, the golden rule is to keep your memory files under 10,000 tokens. This preserves 95% of its context window for the actual code. And if you want to take this even further, there's a great community tool called Claude Mem. While the 4 levels we just discussed are for rules, Claude Mem is a plugin that captures your entire history. It's a great way to ensure you never lose context between sessions, especially on massive projects. Then we have OpenClaw, formerly CloudBot or Molbot. With OpenAI recently acquiring and baking it, this is moving from a niche tool to an industry standard for agentic engineering. OpenClaw's memory is different. It's not just sitting in your terminal. It's out in the world, interacting with websites and CRM systems. How does it work? It manages its own state and history to navigate complex, multi-step web interactions. When to use it? When you need a fleet of agents to perform actions like web scraping, data entry, or automating business processes that run on repeatable SOPs. But there's a trade-off. Because it acts as passport to your data. You must implement strict sandboxing and permission limits, among other crucial security practices that we'll cover in another video. One of my colleagues asked a great question a few weeks ago. Is memory just having the context at hand, or is it a grep search? It's actually both, but they serve completely different roles in your infrastructures. First, we have dynamic memory, like Claude Code or OpenClaw. This is just-in-time context retrieval. The agent reads and writes to a memories directory, usually in XML or Markdown, during execution. It doesn't load everything at once. It only grabs what it needs for the current task. It's the agent's experience as it works. Then you have context caching or problem caching API. This happens at the infrastructure level. When you send the same massive block of documentation or system prompts repeatedly, the provider caches it on their servers. The difference is in the ROI. Cache tokens cost a fraction of normal input tokens. The caches have a time to live. If you change the beginning of your prompt, the cache invalidates. In a real production environment, these are layers, not alternatives. You use dynamic memory for the task, progress, and state, and context caching for the heavy static documentation and rules that you send with every single prompt. So how do you synthesize for this production-ready system? As I'm sure you've heard before, AI is only as smart as the prompt you give it. This is the modern version of garbage in, garbage out. If you use Claude Code to standardize your workflows, you ensure quality in. If you use OpenClaw to manage your business process automation, you ensure scalable action. And if you use context caching for your data storage, you ensure efficiency. But here is the strategic warning. Do not over-optimize for today's scaffolding. The models are evolving so rapidly that custom vectors stored your build today might be obsolete tomorrow as context windows get bigger. Build for where the models are going, not where they are today. Before we wrap this up, let's talk about the risks that sometimes like to stay in the shadows. The biggest threat to agents with shell access like OpenClaw isn't getting hacked directly. It's indirect prompt injection. Imagine your agent summarizes an email or a web page. An attacker could embed a hidden instruction in that content, invisible to you but clear to the AI. That instruction could tell your agent to exfiltrate local credentials or modify system files. Cisco's AI security research recently flagged this as a systematic risk. While OpenClaw uses a low list, which are basically whitelists of approved shell commands, the model is still processing untrusted content with access to your local environment. For any enterprise-grade production, these are 3 things that are non-negotiable. 1. Human in the loop. Use approval gates for any irreversible action. No RM, RF, or code commits without a human OK. 2. Read-only mounting. Mount your sensitive documents as read-only. If the agent doesn't need to write, don't give it the pen. 3. Dedicated API keys. Create separate keys with strict daily spending limits. And please, never run an AI gateway on your personal machine. Use a dedicated sandbox environment like Docker or separate VPS. To summarize the debate between Claude Code versus OpenClaw, choose Claude Code for standardizing internal engineering workflows and OpenClaw for autonomous agentic tasks, but secure them both with robust sandboxing. The roadmap for an engineer is shifting from writing code to managing these fleets of agents. So, which path are you taking? Are you focusing on standardizing your internal workflows with Cloud? Or are you building autonomous agent fleets with OpenClaw? Let us know in the comments below. Don't forget to subscribe for more technical AI insights.